Good morning, everyone. Today we're going to explore two central types of chemical bonds, iconic and covalent bonds. These bonds dictate how atoms combine to form the molecules and compounds that make up the world around us. By understanding these bonding mechanisms, we gain an insight into the properties and behaviors of different materials at the molecular level. It's presented by me, Mohammed Biwaji. Now we'll move into the content. Here's what we'll cover today. First, we'll discuss ions and their electronic structures. Then we'll explore how iconic bonds are formed, followed by a deep dive into covalent bonds, including their types, side, double, triple bond. Lastly, we'll touch on how to represent covalent molecules using dot and cross diagram, which I'll present. Okay. Let's start with ions. An ion is a charged particle formed when an atom either gains or loses an electron. These create an imbalance between protons and electrons, resulting in a net charge. Atom forms ions to achieve stable electron configurations, typically similar to noble gases. For example, sodium ion. Sodium ion uses one electron to become positively charged. When chlorine gains the electron chlorine gains one electron to become negatively charged. So it does the opposite. So here are the types of ions that we'll dive into. These are main types of ions. Cations are positively charged ions formed when atoms lose an electron, such as sodium becomes Na+. Anions, on the other hand, are negatively charged ions, formed when the atom gains electrons like chlorine, becoming Cl-. These oppositely charged ions are building blocks of iconic bonds. Okay, we'll move on to the formation of ions. Formation of cations. Cations form when atom loses electrons. Take sodium as an example. We can see here its electron configuration is 1s2, 2s2, 2p6, 3s2. When sodium loses its outermost electron, it achieves a stable configuration of 1s2, 2s2, 2p6, resembling noble gas. This leaves the sodium atom with a positive charge forming Na plus ion. You can also see in the diagram, it also has a 4 outer shell to achieve this. Now we'll look at the formation of anions and look at examples such as chlorine. Anions, on the other hand, form when atoms gain electrons. For instance, chlorine has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p5. By gaining one electron, chlorine fills its outer shell to achieve the configuration of 1s2, 2s2, 2p6, 3s2, 3p6, making it stable and negatively charged as CO2. So also see an example. Okay, now moving to iconic bonds. Iconic bonds occur when oppositely charged ions attract each other. A good example is sodium chloride. Sodium loses an electron, becomes sodium plus, and chlorine gains that electron, becomes Cl-. The electrostatic attraction between these oppositely charged ions have a strong iconic bond, creating a stable compound. This is a diagram. So here we see sodium and chlorine reacting to form sodium cation and a chloride anion. The electrostatic force is labeled because that's important. Okay, now from an electronic perspective, iconic bond involves electron transfer. For example, when sodium loses one electron, its configuration changes from 1s2, 2p6, 3s2 to 1s2, 2s2, 2p6. Caused by gaining this electron changes from 1s2, 2s2, 2p6 to 1s2, 2s2, 2p6, 3p6. As is seen here, the resulting ions are stable and bond to form sodium chloride. We'll move on to covalent bond. Unlike iconic bonds, which involve the transfer of electrons, covalent bonds form when atoms share electrons. These bonds occur between nonmetal atoms. By sharing electrons, each atom achieves a full outer shell, resulting in a stable molecule. Covalent bonding is fundamental to structures of many organic and inorganic substances. Okay, types of covalent bond. Covalent bonds come in 3 types: single, double, triple. These types depend on how many electron pairs are shared between atoms. A single bond involves 1 shared electron, and a double bond involves 2, and a triple involves 3. Each type of bond has unique properties influencing the molecule strength and behavior. Now we'll move on to single covalent bond. When one pair of electrons is shared between 2 atoms, a classic example is a hydrogen molecule, where each hydrogen atom contributes 1 electron, resulting in a H2. molecule. Single bonds are the simplest type of covalent bond. Now moving to double bonds, double covalent. Double covalent bonds involve the sharing of two pairs of electrons. For example, in an oxygen molecule, each oxygen atom shares two pairs of electrons with another, forming a stable oxygen double bond. Double bonds are stronger than single bonds and often appear in molecules such as CO2. Finally, moving on to triple bonds, involve three pairs shared of electrons. A common example is a nitrogen molecule, which each nitrogen atom shares three pairs, forming a very strong nitrogen bond, as you can see in the diagram. Triple bonds are the strongest type of molecule, are the strongest type of covalent bonds, and play a critical role in molecular nitrogen gas, which make up most of our atmosphere. So, finally, reached a conclusion. Ionic bonds happen when electrons are transferred from one atom to another. This results in oppositely charged ions. Electrostatic attraction arising from the charges of the ions holds them together in a stable ionic compound. Covalent bonds result from atoms sharing pairs of electrons, so each atom has an outer shell with 8 electrons. Covalent bonds may be single, double, triple. These bonding principles are essential for providing a molecular level explanation of how different substances will behave and have the properties they do in chemistry, as these directly impact on their structure, reactivity, and interactions. That is the end of my presentation. I hope you enjoyed it. Thank you.